Have you ever just stood and looked at a massive river and really thought about the sheer, raw power that's flowing right in front of you? Well, today we're going to dive right into that. We're exploring the incredible world of hydropower and how we turn the simple act of falling water into the electricity that, basically powers our entire world.
It really all starts with a question that sounds a bit like a riddle, right? How does one single drop of rain actually help power an entire city? Well, the answer is this amazing story of nature, incredible engineering, and honestly, a ton of human ingenuity. At its very core, the amazing thing about hydropower is that it is the ultimate renewable resource. It's all powered by the water cycle, the constant movement of water on, over, and above the Earth. This is a natural process that's been humming along for billions of years, and it's not stopping anytime soon.
And when I say powerful, I mean it is immensely powerful. The force of gravity just pulling water downstream contains this colossal amount of energy, all of it just sitting there waiting for us to tap into it.
Now, this idea isn't exactly new. Humans have used water wheels for centuries to do things like grind grain. But it was really in the 20th century that we took this ancient idea and just scaled it up to a mind-blowing level, building these colossal structures to meet the demands of our modern world.
So, let's get into it. Where does the energy in that falling water actually come from? You might be surprised to learn that it all kicks off with the sun. Yeah, you heard that right. In a way, hydropower is basically a form of solar energy. The sun is the engine that drives the whole water cycle, lifting water up into the atmosphere. It then falls back down as rain or snow, and gravity takes over from there. All a hydropower plant really does is put itself right in the path of that water's inevitable journey back down to the sea.
And once we figured that out, well, it led to this incredible era of massive construction. Our ambitions just kept escalating. Back in 1936, the Hoover Dam was this incredible symbol of human power. But just a few decades later, you get the Itapu Dam, which absolutely dwarfed it. And then in 2008, China's Three Gorges Dam set a totally new global standard, producing a staggering 22,500 megawatts of power.
Okay, but how exactly do these giant concrete structures convert flowing water into the electricity that's, probably charging your phone right now? Let's break down the engineering. It's pretty cool.
It's really this beautifully simple four-step dance. First, the dam holds back water, creating a reservoir. Think of it like a giant water-filled battery, just storing all that potential energy. Step 2, when the gates open, gravity yanks that water down through a huge pipe called a penstock. Step 3, that powerful jet of water smacks into a turbine and spins its blades, kind of like a pinwheel in the wind. And finally, that spinning turbine turns a generator, and voila, mechanical energy becomes electrical energy.
But, and this is a huge but, for all its clean energy promise, hydropower is definitely not a perfect solution. It actually presents a really complex and, frankly, often controversial dilemma.
On one hand, you've got this incredible promise, right? A reliable, renewable power source with zero air pollution and super low running costs. Plus, dams give us critical things like flood control and water for farming. But there's a really steep price. Dams fundamentally change rivers. They block fish from migrating, they flood huge ecosystems, they can displace entire communities, and they can mess with the flow of sediment that downstream habitats absolutely depend on. And this isn't just some historical issue from decades ago. Look at this. This quote is about a recent project. Over 15,000 people were displaced. It just goes to show you the very real human and cultural costs that can be wrapped up in these massive undertakings.
So that's the big question, isn't it? How do we solve this dilemma? How do we keep the promise of all that clean energy while somehow lowering the environmental and social price tag? Well, the answer, it turns out, lies in technology and innovation. A major focus today isn't even about building new dams, but on upgrading the ones we already have. It's kind of crazy when you think about it. The average hydro plant in the United States is over 60 years old. It's running on last century tech. So modernization is absolutely key to making them more efficient and shrinking their environmental footprint.
And one of the most game-changing technologies here is something called a digital twin. Okay, imagine this, a perfect virtual copy of a real power plant living inside a computer, constantly fed with real-time data from thousands of sensors on the actual equipment. Operators can test upgrades, predict when a part might fail, and figure out the best way to release water for both power and the ecosystem, all in a simulation without any risk to the real thing. It's amazing. And that's just the start. We're seeing this whole new wave of smart solutions tackling these old problems head-on. Engineers are designing fish-friendly turbines that let fish pass through totally unharmed.
AI is being used to schedule water releases that actually mimic a river's natural flow, helping to heal ecosystems. And we're even seeing hybrid plants that pair the consistency of hydro with the power of solar and wind.
So with all these incredible innovations coming online, what is hydropower's evolving role in our future energy mix? Where does it fit in?
Well, first, let's talk about efficiency, because this number is just stunning. Modern hydroelectric plants can convert about 90% of the available energy in the water into electricity. That makes them one of the most efficient power sources we have on the entire planet.
But its most vital role today might be as the ultimate team player for the power grid. See, unlike other power plants that can take hours to ramp up, hydropower can go from 0 to full power in minutes. This makes it absolutely essential for keeping the grid stable. It can instantly fill the gap when, say, the sun isn't shining or the wind isn't blowing. It's really the reliable backbone for a renewable future.
So we kind of end up right back where we started, thinking about the power of water. But now we can see the full picture. The question for our future isn't if we should use this incredible force, but how we can do it wisely, balancing our desperate need for clean energy with our duty to protect the natural world. If this explainer helped you understand the power of water, be sure to like and subscribe for more deep dives into the technologies shaping our world.